Hello everyone, in this tutorial I'm going to be showing you how to make a simple character controller. So the end result will be something like this. As you can see, we can move, we have character controller, no double jumps, very smooth. And if you want me to add mouse look or maybe make this into a series and make a first person shooter, just let me know down in the comments below. So I already have a blank Unity project. It doesn't really matter which version you use. I'm not going to be using anything special for this one. Just make sure you already have a blank Unity project. So first, let's create a ground plane for our characters to stand on. Now I'm going to center it like this. You don't have to follow along. Now let's just scale it a bit. We'll just do the 100, and I like to keep my things, organized. So I'm gonna add a folder called material. You don't have to do this. This is just optional, just to add a different color to the cube, because I don't love the very bright white. Actually, I'm gonna make this black because yeah, this is way better for you guys. So now let's create our ground player. So we'll just go to the object, bean. So we're gonna name player. Now let's click select the player, drag him up. Now let's put our camera so that it sees the bean. So sorry, we can just drag it away a bit, and yeah. Now let's add a rigid body component to it in a new script called character count. You can name the script basically whatever you want. I just love to name my script like that. So the first thing we're gonna add. Okay, so now let's actually open up the script, and to keep things organized, in a folder called scripts. If this is going to be a long-term project, it's better to start organizing stuff beforehand. So, yeah. Okay, we've got our project open, we've got our script open. Okay, there we go. Now we won't be needing the word start. Let's just reference the rigid body real quick. If you don't get what this means, this is basically the same thing as just saying rigid body RB, and then just saying RB is equal to get component rigid body. If you want me to cover that arrow, which is called lambda, let me down below in the comments again. I will definitely make sure to do it. So I like to keep my thing with lambda. Because so now let's check if the space button is pressed. So if input, we get key down key code dot space, not escape. We don't want escape. So now let's apply physics to it. So our rigid body dot add force, and then we'll just say vector 3 dot up times speed. No, it's actually sorry. Let's just define float speed, and let's make it serializable. Serialize field. Over the the years I've learned how to spell serialize properly. So and then we want a force mode. So force mode dot force. So I'm gonna show you all the force modes. So basically, what force mode the force does is a continuous force of the rigid body using its mass. The mass is the mass of the rigid body is this. So if we were to set it to 5, then it would won't jump as high. So we don't actually want to use the mass. So but what will we use? So this acceleration, we don't want acceleration because it's just accelerating. We don't need an acceleration. An impulse might be used for something like recoil. And again, it's using its mass. So I think velocity change is appropriate for this as an instant velocity change to the rigid body, which is the jump, and ignoring its mass. So a good practice for this is to do the physics in fixed update, because update actually runs every rendered frame. So if you were to play on your grandma's 1980s computer, there might be like 1 frame per 5 seconds, and so the physics would be correspondingly like that. But fixed update runs a fixed amount of time, so the physics will actually update. So fixed update is basically update, but it runs a fixed amount of times per second. So, and the delay I think is 0.02, I believe. So you can change it in the Unity settings. So we've got this, but how will we? Let's take a look what happens. It won't work, and for a reason, because now first of all we didn't set speed. So let's set speed to something like 6. This should not be called speed. This should be called jump. Times jump. So vector 3 is basically a direction with a magnitude. So I can explain that in depth. I just want to make this quick. So it won't work because we'll just apply continuous force. We actually need to check. So it won't work. It won't even work like that. Like, we still need to check. So let's say bool has jumped. So input here has jumped is equal to true, and then if has jumped. I like to keep it curly brackets. If has jumped, then we say has jumped is equal to false. So as you can see, it is not working because again, I need to set a jump to something appropriate, like maybe 6. And as you can see, our jump is perfectly working. I did not modify any of the code. This is still the code. Now, if you don't have enough time, then I can link the code down below. So okay, we got the movement. Nice. Now let's add the actual movement with the arrow key, so WASD. So what we actually want to do is we want to say float horizontal movement, and then we just want to do the same thing for the vertical movement. So I think the IntelliSense actually suggested vertical movement. So good. Now we're gonna say horizontal movement is equal to input dot get axis horizontal. Now, if you're wondering what this means, I just want to show you quickly. So, go to File, Build Settings, Player Settings. Go to Input, or is Input? Input Manager, yep, there we go. Then go to Axis, Horizontal. So this, as you can see, look, this is basically, instead of asking for the left and right keys. So it basically takes a float, like basically how hard and for how long you press on the keys, and it just then you can use that to multiply your velocity. So we can rename this to H, but I don't want that. And just to make sure my spelling is correct, we're gonna copy this. And it looks like it was correct. Now let's do the vertical, and we're just gonna say vertical movement is equal to put.get axis. No, I want to keep this as brief as possible, although it's not really brief now. So I can make a separate tutorial for all of this. So now what we want to do is we want to set rigid body dot velocity, and as it says, it's just basically velocity. I'm just gonna say, okay, so we have this. I can make a separate tutorial for all this. So we don't actually want to set this to 0 because it will basically look what will happen if we set this to 0. You see, the rigid body is constantly fighting with the velocity because the rigid body falls on its own, but constantly setting the velocity to 0. It's doing that slow. And plus, it's working now, as you can see. But when we reach the ground, look what will happen. Bam! We tumble over. We can easily fix that. So, first of all, we need to say this. Not this, but rigid body dot velocity dot y. What this basically does is it takes our velocity of y, and we're not changing it. We're just taking the same thing. Now, to fix the tumbling over bug, we have to go to rigid body constraints, and this is where we can see freeze position. So we don't want the player to move on the z-axis. I can show you what will happen. It means to freeze the rotation because we don't actually want our character to rotate. So we don't want our character to do some spinny Simon the Hedgehog, I don't know, tumbling thing. We want him to stay in one, in one rotation. So there we go. We fall good. We fall fast. So as you can see, we can move like this. It's kind of slow. We can fix this. But when I'm actually pressing the S key, nothing is happening. Why? Because we have frozen the Z rotation. Now that I've frozen it, our character moves. So you should have character moving by now. Now let's actually create a serialized field called speed. And what will we do? We will multiply this by speed. There we go. So the character control is pretty much done. Although we still have the power to multi-jump. And I don't know about you, but I don't want it. So we have oops. Yeah, I didn't set the speed, sorry. I just set it to something like 6 also. So we have basic character movement, but there's multi-jump. So there we go. We have it like this. Oh, sorry. I freeze the Z rotation, so we don't want this. So now it should work. So there we go. We have a nice character movement, pretty fast. But we can multi-jump. We don't want to multi-jump. Like I don't know about you, but I don't want to multi-jump. So there's an easy way to fix this. So there's one way. So one way is to fix it. Sorry, I had a few interruptions. So what I was going to say is we can do this a couple of ways. So number one, we can just check for collision. So void on collision, enter, and then on collision exit, and we want to say bool is grounded. So let's just say is grounded is true, and is grounded is equal to false. So it will perfectly work. So look, okay, the Z rotation is empty. So oh yes, sorry about that. It won't work because so this and is grounded. This will work because we didn't actually check. We assigned the value, but we didn't actually check. So yep, and as you can see, as you can probably hear, I'm mashing the space key, and this will not work. No double jumps. So the only problem with this, like the obvious problem with this, is that, for example, you have another platform here. Like for example, right here, you're standing on like the very edge. For some reason, the collider doesn't check. It doesn't check. Like it doesn't check the collision. So you're just gonna be left there without jumping, and sometimes you can't even move. So that is the only issue. Now the other way to do this is to do something like this. So I can say is grounded is equal to, this might be a bit complicated, physics dot overlap circle. Wow. Oh wait, no, I'm sorry. Of course, it's a bit. So I'm kind of stupid. Overlap sphere. I'm sorry. So as you can see, we need position, a radius, and a layer mask, which is optional. So overlap sphere. And what we actually want to do is we want to go in here and create a ground object. So we can go right here, create the object, cube, right? We're gonna center its position, nice, in its relative position. So 0.01, 0.01, 0.01. So yeah, there we go. It doesn't really matter how big the object is, just for it not to be visible. So there we go. Now we want to say, actually want to reference this object, so we want to say serialize field and game object ground check. There we go. And actually we're gonna do it as transform. As a transform because transform. Because I don't actually want to write transform dot position. I just want to write position dot position. Ground check dot position. Check dot position. Okay, ground check dot position. Then we want a radius. Let's just say 0.1f. And there we go. So now this returns an array, so we can access the array's length by using dot length. So what we want to do is we have, and it doesn't belong to the object necessarily. It just means it's in that position checking. So there's gonna be at least a minimum of 2 colliders always. Minimum of 2 colliders always. So it's gonna be the ground check collider. So I should rename it to ground check. Ground check. And the player. So there's always gonna be 2. So we can just say is equal to 2 or is more 2. So if it is more than 2, then we say is grounded is equal to true. Then we just say is grounded is equal to false. So now this should work. And yeah, it should work. So if it doesn't work, then we can just stick with the other answer, or I'll just link the working code. Oh, the ground check is not going to sound good. Yep. There we go. Ground. Oh, sorry. Ground check. Just, yeah, the object. Okay, good. So yeah, it works. Why does it work? Well, because look, we have. Sorry, this tutorial is a bit messy. It's because it's my first one. I'm really trying my best. So, why does this work? So, we have, and for those of you that don't know, this is basically an if statement. So, it's basically the same thing as writing if physics.overlap, and we just write this, and in the dot length is equal to is more than 2. Then we say, then curly brackets, we say is grounded is equal to true, and then we write else is grounded is equal to false. This is basically the same thing. This is called the ternary operator. So what we're basically doing is physics.overlap sphere ground check position. So what this does is we're checking from this position with this radius. So it starts from right here, for example, then goes up until here, and up until here, and up until here. It goes in all directions, and it checks. So, and then it returns an array of objects that touch it. And so if the length is more than 2, and the default is 2, because it will always collide. It will always collide with the this thing, the ground check, and the capsule. So if it's more than 2, then we are grounded. We're standing on the ground. We're touching something. Now this could occur with platform jumping, but I can get into that later. I could show you how to fix this, because I could use a raycast. So now we have is grounded is equal to false if it's less than or equal than 2. And so that's how it works. So I hope you enjoyed this tutorial. Please subscribe. This is my first tutorial. I'm sorry if it was very messy. It's really kind of long. So if you have any suggestions for the next tutorial, please leave a comment down below. I very appreciate you. So bye. See ya.